In one, you're going to be asked to identify or test to see whether a given ordered triple. Okay? So an ordered triple is a point x, y, and z. Okay? As far as 3 dimensions go, as far as what you're finding on these, we're not going to sketch the graphs of these. You'll probably do that next year. But in this case, you just need to know how to find these ordered triples. And so what you're going to be doing for this first set of problems is you're just going to test it to see, does a given solution set work for all 3 equations involved? And you can do one of 2 things. One, you could physically plug these in for x, y, and z and see if the statement holds true. So if you're doing something like that, you would get 3 plus a negative 2 plus a 1 and test to see, does that equal 2? So 3 minus 2 is 1 plus 1 equals 2, so that one checks. Here, if you plug in 6 times 3 minus 4 times a negative 2 plus 5 times 1, you can check and see, does that equal 31? Well, here's 18, minus a minus becomes plus 8 is 26, plus 5 is 31, so yes, that checks. And then the last one, 5 times 3 plus 2 times negative 2 plus 2 times 1, does that equal 13? And so again, if you're checking these, you have 15 minus 4 is 11, plus 2 is 13, and so that checks. If all of them check, then your answer is yes, that is a solution point. Okay. Now, there's another way that you can do this, and that is you could just simply solve for the system and identify, is there an answer? Okay. If it is this the answer? And if it's not, or if it's any of the inconsistent or dependent systems, then you would say no. So the other possibility would be to just plug all 3 of these equations into your system solver and find what that solution would be. Okay? Let's review how to use your calculator's system solving template. Okay? So let's do this second problem using the calculator. So we're able to verify that yes, this is a solution by hand. If we want to set up our second equation to solve, okay, the system solver is located in the custom tabs region. You can switch to the custom tabs by hitting second home. That brings up this different set of tabs, and under the F3 solve tab, you can scroll up. And this is our system solving template. Now notice though that this template is designed for 2 equations with 2 unknowns. And what we're doing in these extended 2 sections here of chapter 11 is we're working with ordered triples. And so here what we might need to do is extend this out. And so if you just go into your braces and add the new variable z, and then inside you're going to create, if you have 3 variables, you need 3 equations to solve. So I'm going to alpha lock this when I move my cursor before my comma. And I'm going to type in the word A and D, and, because I know I'm going to need to, and then a space bar. Remember the space bar is alpha, then this change of sign key. You can see it look like a little underscore in this white key. And so then I can deselect alpha, and I can go in and I can type all my equations. So I'm going to go ahead and just type x plus y plus z equals 6. Move after my and. Notice I do need another and here, so I'm going to choose alpha and put another space. But here I'm going to write my second equation, 4x minus 9y plus z equals 74, and then scroll after my and, type my last equation, x plus 6y minus 5z equals negative 75. And so there's all 3 of my equations written. Once I do this, I can hit enter, and it's going to either give me a solution. Okay, so here it does provide a solution. So these 3 equations here do actually have a solution. Is the solution 4, negative 6, and 8? No. So I know that my answer on this would be no.